Greetings, Patriots. We are going to go ahead and set up your work area, right? Your math notebook. One of the vocabulary words that we will be talking about today is unit rate. And we've been talking all week about constant rate of change. And now I want you to think about how these two are related in regards to the lessons that we do today, okay? So please take time to set up your guided notes. You can make a table, you can draw it. If you are able to print the guided notes, you may do so as well. Our objective for today is I will find the unit rate in multiple representations. And I want you to think about, well, how is the constant rate of change and the unit rate similar or different? How do they compare? Maybe that's something we will definitely talk about. All right, so constant rate of change we know is that same rate, right? It stays the same, it doesn't change whenever I'm looking at two different quantities. Unit rate is also used to compare quantities in which the second quantity though is out of one. So I always like to reference this prefix here, this part of the word unit, uni, okay, which means uno, right? Out of one. So that's sometimes helpful for students to remember. So another example in our vocabulary. So you may want to take the time to write that in your notes. What is a unit rate? It's a comparison of a number to one in different units. So for example, if I'm comparing students in classrooms, here it says I can have 120 students in 4 classrooms. Well, if I divide that by 4, 120 divided by 4, that's going to tell me that I can actually have 30 students in 1 classroom. So remember, it's always a number being compared to 1 in different units. So my units are students and classrooms. Here's another example, 29 grams per cubic centimeters. Well, I want to know that rate in reduced to 1, right? So in 1 centimeter. So everything is per out of 1. So when you think of a unit rate, you must have that in your fraction, you must be comparing it to 1. Okay, we're going to talk about some examples in real situations. So let's say we're given this situation, right? Maria's walking 12 miles in 3 hours. Well, definitely I'm comparing two quantities. And the two quantities I'm comparing here are miles and hours. So they told me that in 3 hours, so here's my table, in 3 hours, she can walk 12 miles. Well, then that means how many miles is she walking for 1 hour? That's my unit rate. So I can take that and divide 12 by 3. And 12 divided by 3, right? If I divide by 3, that's going to give me 4 miles in 1 hour. So my unit rate would be 4 miles in 1 hour. So if I know my unit rate, I can figure out 2 hours, right? So every hour, if it's 4, that means 2 hours is going to be 8. 3 hours is going to be 12. 4 hours is going to be 16. Do you see the pattern? So our unit rate is important because it really gives you that same constant rate of change that's happening from hour to hour. Remember how we were comparing in our tables. So again, if I look at this, how am I getting from 1 to 4? Well, let's see if I multiply by my unit rate, if that will give me the next set. Yep, 2 times 4, 3 times 4, 4 times 4. Well, I know then to get the total miles, right? My miles, all I got to do is multiply my unit rate 4 times the number of hours. How else can I write that? Y equals 4x. So if we compare our hours and our miles, my graph should look like a nice straight line. Okay, so here we go. I'm going to go ahead and choose my intervals of 8, 12, 16, 20. So if Maria walks 0 hours, right, 0 miles, well, she didn't walk that day. 0, 1 hour, 4 miles. 2, hours, 8 miles. 3 hours, 12 miles, and so forth. So you can see that nice constant rate of change again in your graph, okay? 4 miles per hour. Well, what if you were asked, well, how many miles can she walk in 7 hours? Well, that's easy. I can use my equation or I can use my unit rate to help me out. 7 times 4 means she would have walked 28 miles. Okay, let's look at another example of a unit rate. Well, when I'm comparing gallons, right, of gas and miles, how many gallons does it take to go to drive? Well, here it says that Steve is actually driving 78 miles on 3 gallons of gas. So we know that he can go 78 miles on 3 gallons of gas. Well, I want to know how many miles he can get for 1 gallon of gas, right? So again, if I take 78 and divide that by 3, that's going to give me my unit rate. And that's one thing that you definitely want to always do is find that constant rate, that unit rate. And this tells me that he can go 26 miles on 1 gallon of gas. Okay? 26 miles on 1 gallon of gas. So let's see. How can I take my unit rate? Once again, I can take my unit rate and multiply all of the gallons I'm given. 1 times 26 is 26. If you multiply 3 times 26, that's going to give you 78. So guess what? How much is 6 gallons? Well, let me multiply 26 times 6, right? And when I multiply that, I get 156 miles, and so forth. I can multiply 8 times 26 by my unit rate. If I do that, I'm going to get 208 miles, and so forth. If I want to know how many miles I get for 10 gallons, I'm going to multiply that by 26, and that's going to give me 260. So forth. So again, my equation, in order to get the total number of miles, all I have to do is multiply my unit rate of 26 miles per every gallon. Okay? So if I take the time to graph this as well, I know I have gallons here and miles on my y-axis, and I can go ahead and choose an interval of 1 here if I wanted to graph a little bit of the ordered pairs on my table. So if I want to go ahead and do this, I'm going to go ahead and skip count by, let me go ahead and go by tens. And I can hopefully grab a few. Maybe not. I may have to go by 20s. So 20, 40, 60, 80, 100, 120, 140, 160, and 180, and 200. Okay, so there's my miles, right? And my gallons. So if I go ahead and multiply, right? I know that at 0 miles, 0 gallons of gas. At 1, it was 26, so I'm going to be somewhere around right there. At 3 miles, it was 78, so that's a little closer to 80. At 6 miles, it was 156, so I'm going to go get a little close to 160 up there. And once again, though, what's important here, and then let me go to 8 miles. That's going to be a little bit above the 200 right there. But if you see that, I'm getting that nice constant rate of change, that nice line, okay? So, once again, I can use my equation. I can see the connection to my unit rate on my table as well, and so forth, okay? So, what if they give me 130 miles now? So, they've given me the y variable. So, if they tell me that I have 130 miles, and that means they want to know, well, how many gallons of gas is 130 miles. Well, if I take 26 times some number of gallons, that has to give me 130. Well, what can I do? I can just divide these two. I can also divide by the unit rate in order to figure out the number of gallons. So if I take 130 and I divide it by 26, that will equal 5 gallons. So 5 gallons of gas, right, will get me 130 miles. Okay, let's go ahead and try another example. If you feel like you're ready, you go ahead and try to find the unit rate, okay? This is a we do. You score 84 points in a game, in 6 games. So I'm looking at the points and the number of games, right? Those are my two quantities. I want to know how many points were scored in one game for my unit rate. So I'm going to start by taking 84 and dividing that by 6. And when I get that, I see that I'm scoring 13 points in one game, okay? Oops, I did a mistake. Sorry about that. Miss King, okay, I meant to not say 13. I meant to say 14. Oops, oops, oops. Okay, there we go, because 6 times 4 is 24. So that would be 14 points in a game. Okay, so once again, if I have 14 points in a game, right, that is my unit rate over one game. Well, I can use that unit rate because I already know my equation is going to be that to get the total of points, it's going to be 14 times, right, the number of games, since I'm scoring 14 points every single game. So if I want to figure out 4 games, well, all I'm going to have to do is multiply, right? 14 times 1 is 14. Now I'm going to have to multiply 14 times 4. And when I multiply that, I get 56. All right? 14 times 6. Right? If I do 14 times 6, I'm going to get 84 points. And that one was actually given to me. 14 times 7 games would be 98. And of course, 14 times 10 would be 140 points. So, if I look at my graph, I should also begin to see that nice constant rate of change in my graph. So let's say I was just going by ones, and I'm just going to graph a few here. I know that I'm going every 14 points, right? So that's 14, that's 28, and then if I add another 14, that's 42 points. If I add another 14, that's 56 points. If I add another 14, that's 70 points. And then if I add another 14, that would be 84. So I'm going to go ahead and have an interval of 14 points. So if I don't play any form of games that day, that would be 0, 0. Okay, if I play one game, I know it's 14 points. If I play 2 games, it's 28 points, since that's my unit rate. If I play 3 games, that would be 42. If I play 4 games, that would be 56. If I play 5 games, that would be 70. And of course, if I play 6 games, that's 84 points. You can see once again that constant rate of change, that rate of 14 points for every one game that I play. Now you try. Okay, if I have a pump that is moves 42 gallons, okay, in 7 minutes. I am comparing gallons and I am comparing minutes. Go and try to find the unit rate for 42 gallons in 7 minutes. You can stop and try. Welcome back. So if I want to get the unit rate of 42 gallons in 7 minutes, well, I know that that would be 6 gallons in 1 minute. So that's going to be my unit rate. 6 gallons every single minute. So again, if it's 0, 0, right? 0 minutes, 0 gallons. So that means I'm multiplying by 6 every single time. And my equation would be y equals 6x. So in 4 minutes, if I multiply that by 6, that's going to be 24 gallons. Okay? In 7 minutes, if I multiply that by 6, and that's what they gave me, that would be 42 gallons. If I have 11 minutes pass and I multiply that by 6, that would be 66 gallons. So now notice they've given me 30 gallons. Well, perfect. They've actually given me, they want to know the number of minutes that it takes. So I can use my equation to help me solve for this, right? Or I know my answer has to be between 4 and 7. So I can check 5 times 6 or 6 times 6 has to give me 30 gallons. Well, I know that when I take 30 and divide it by 6, that's going to give me 5 minutes. Okay, because 5 times 6 equals 30 gallons. All right, I can go ahead and graph this as well. And if I'm looking at the number of minutes, right? And I know that my gallons is increasing by 6. Here's my minutes, and here's my, here's my minutes, and here is my gallons. And I'm going to go ahead and graph this. I'm going to choose intervals of 6, right? So here we go. I can graph at 0 minutes, 0 gallons. At 1 minute, 6 gallons. At 2, 12 gallons. At 3, 18. At 4, 24. At 5, 30, and so forth. Once again, you see that unit rate right here, right? Always out of 1. That's how you find that unit rate. So I can look at my graph and that helps me find it. Okay, so I want you to think about in maybe our discussion question tomorrow, how is constant rate of change and unit rate similar or different, right? And you can tell me, well, the constant rate of change and unit rate are the same because, or they're different because. So once again, in this unit lesson, you were supposed to find the unit rate, and we did that in multiple representations. So you got to see the unit rate in a table, in an equation, and in a graph, and in a situation. So make sure you think about how is the constant rate of change and unit rate similar or different. Have a great day, Patriots.